All right, so let's start
Okay.
with Sol.
Hi, everyone. I will be talking about sine waves, pSine waves, a little bit of introductions. I'm a programmer. I work as a full stack programmer. I code in the day, code in the night. I love computers. I have a background in math, and once in a while, I come with wondering stuff like what if things. So a little bit to motivate this talk. I was thinking a lot on what are like sine waves in different metric spaces, or what if we like change them? Because sometimes like observing the same object in a different way, you can get more insights. So I want to share with you my process of approaching this whenever I have a what if situation in my head, how I actually coded. I'm also sharing code. I did a GitHub repository, and hopefully a little bit of a demo and have fun. So to start, I think most of us are familiar with what sine waves are, but I like introducing them as circular functions. As well, I will say, like, imagine we are walking at a constant speed, distance one through the origin or through another point, and then we track like the y coordinate of that distance that you have been walking in the like the arc length. Then that is a sine. So basically, you walk along the path of all the points distance once from the origin, and you get the height or the y coordinate. And well, this actually I will mention a lot the unit circle, and the distance is something that we are assuming mostly all the time. I think when we learn math, like distance is something that it's there, and we never really question or think about it. So if we want to measure like 2 points, A, B, and we are like just taking like the blue line, yeah, that's how we measured. But we need like a referential context. We need a space, and in this space we can like actually describe the positions of the points. And once we describe the positions of the points, we have like, yeah, like that formula that it's really like, thank you Pythagoras for giving that. But once we have the distance, it's like, okay, let's build all our geometry notion on top of this. And if we kind of generalize this notion of distance and we swap like the 2 by p, then we have infinite numbers of distances, like yes, with p in a positive range. And this introduced like what a p norm is and LP spaces that are basically yes, all the spaces, which here I put the unit circles. I don't know if you see them, but the unit circles change according to the p-value. So then the circle in p equals 1 would be like a diamond shape. The circle in the infinite or in a very high value would be similar to a square. And with this idea in mind, I was like, well, actually, with less than one, we don't have norms, but it's still fun to play. And with this in mind, I was thinking the sine wave, like, okay, I am like walking through these different, unit circles. And actually, if you do it, like you will walk, like if you start with p equals 1 is the triangle shape, like triangle sound. If you like increase, it's like a square wave. So then you have this smooth interpolation between all sine waves, which is very fun. And I'll do a little demo. I'm really not tracking time, so let me know if I am. Yeah, I will do first visual demo because I'm a visual person. Mostly, I'm not sure what I am actually, but yes, I don't know if you are familiar with shaders, but if you want to like draw, let's do like this circle. We use these sine distant functions, and this is not what is wrong. Oh yeah, no, yeah. Syntax error. Yes, parentheses. Yes, here. So this is the I'm using the function length, which is the Euclidean length. that we first saw. And then here I define like the p length, which is the generalization of the length. And we see that if we change here values, you can go from diamonds to squares to shapes in between. We can use like a little bit of motion. And we can also not just having like shapes, different shapes, but change motion. So if you are familiar with how to parameterize a circle, yes, we just saw it. This, yeah, and I could also, let's a little bit like that. And if instead of using this, we divide it by the p length. And here I will, yeah, let's do like this. And yep. Maybe I should have coded this before. And here, let's say, yes, and I will add a little bit of feedback, and I will leave it as a circle so we can see. Yes, a circle a little bit bigger. So here, if like I use the value 2, again, we can go a little bit faster, will be the motion of a circle. And again, we can have like motion of a diamond shape or a motion of a square thing. So now that we have like, at least you get some concept of what this is, I want to share with you an experiment I built in Super Collider. So first let's do like this. And hopefully will be sound and visuals at the same time if things don't crash. So I tested and this was working, so we can play it again. And here, I will just get, well, maybe I can try everything. I want to map now, like frequencies to the visual part. I'm not sure if this is gonna be, so now we have like a frequency, a major third, perfect fifth, and octave. And if with that, I don't know where my controllers are. Yeah, like now I will put the fundamental like in a square. Like we can change. Where is my controller? I think you got the idea. It's like playing with different like shapes of the sine wave, which was like a fun experiment. And with the trajectories, you can see, I actually also find it very nice to have like this visual and audio way of mapping, because another example could be introducing a shape as a Ray Martin world. I don't know if you see my screen. Is it bright enough? Yeah. And let me add a little bit of color, and yeah, and things you can control again with these things, like the shapes. I don't know if you ever coded these things like sine distant functions, like doing squares and circles. It's not that easy to interpolate, and now we have everything into like one function, which is very nice. So we can leave cubes, and then we could also control like the camera movement. Like imagine the camera we can move it like circles, or we can like change it. So this, I think it's receiving the second one. I should really do something with these sliders. Yeah, if like we do it like that, it's like it's doing the shape that was. I think we can see it here. And I will. If it's smaller than 1. Okay. Yeah, look at the blue one thingy. So the blue one will be moving the camera, and the red one is defining the shape in this world. So the camera is being like that. And from there, you can like, it's really fun. Like, I don't know, there's a lot of explorations. I think we are done with this sine wave, which can be very relaxing also. I will free the sound. Okay. And I also did, this is for like title users, which I guess it's mainly more people. I defined the pSine, I called it, and I'm really not a title person yet, but I tried to do some examples, and I think it's fun. Like, yeah, this is very slow. This is basically iterating like the p-value in between 0.5, 1, it's like the diamond shape, 2 is a circle, and this is a square. So it's basically listening how they look different. And then you can like create stuff. I didn't do something very nice about this. To show actually the function, like the... I think like in the first channel, you can see how it goes like from circles to triangles to whatever. And yeah, I think this was, I don't know how to uncomment. Ah, this is not my editor. Like this. Yeah, I don't know. You can play. But basically, I wanted to like share these things. And going back, I think I'm okay with time. It was supposed to be short. Yeah, basically how I define the sine function, and this is something that we can talk. I'm just mapping like the sine function that we have in our Euclidean world into the LP units in different units, and this is the demo of what I exactly did. But and yes, and then what, like sound, you can have these smooth interpolations between like waves. Graphics, you can use these values of p in a lot of different places, shapes or motion, and it's very nice to be able like to explore both worlds at the same time. So I did this. I didn't need this backup slide. I had it just in case. I also have this just in case, but no, the supercollider was with me. So you can check the code, or you can write me an email, and I'm really happy to listen to feedback or questions or whatever you have. Yay.
That was very nice. Thanks. Are there any questions?
You're not reading the chat.
Chat, let's see.
Yeah, I really enjoyed that. It's I guess as computer programmers, we do kind of think in terms of discrete things and not all the possibilities between those discrete elements. Recently, I've been getting really into Malcolm Braff's work on Groove. How instead of just dealing with discrete sequences, you can morph between sequences and see the little things in between. And it's just really nice seeing the same idea applied on multiple levels of abstraction. So yeah, thanks very much. I don't have a particular question, but yeah, it'd be nice to explore how to pattern these different things more further in Tidal.
Yeah. Like shift patterns around. With
Okay, we have a question coming in from Barcelona.
Nice. Hola.
Hello, Sol. Can you hear me?
Sí, hola, Iván. Hi.
Oh. Sorry, just a sec. I was muted. Yes, perfect. I don't know if you have create some of these graphics because you are iterating the p-value and you are jumping between a specific grid. And as a mathematician, I probably have thought into finding probably phase transitions or special behaviors according to the p-value you select. Have you find any of these, or it is basically a continuous pattern or a continuous shape going from completely sinusoidal to more triangular? Or is there any, have you find any funny behaviors happening in between of how they behave graphically?
I haven't found any like any pattern, but I've been in a lot of rabbit holes, which were fun. Like maybe sound-wise, like it's you really notice like triangles from like harmonics and from squares. So when you are doing like the interpolation, you kind of like it's nice, and if you like do it with a lot of frequency, then you get like inferent like weird sounds. I had like a really big rabbit hole with the concept of pi. I can bring it up here, and understanding actually like how like pi can have like different values in these different worlds. And that led me to think more of like the properties, of these waves. But I didn't have like any idea on that yet. I'm also thinking like what I'm doing, it's not completely correct. Like I would like to define like maybe it is, but I'm thinking like I'm just taking our definition, like how the computer computes sine functions that is in Euclidean. Maybe if someone knows the answer, then let me know. If I want to define like in a LP space, then I should redefine the sine function or compute it from scratch. You know what I mean? And I've been like thinking a lot about that, if that affects like speed and time. I don't know if you saw, but these shapes that were like smaller than a diamond, like I don't know what is the name. Those are like affecting also time, and you also can listen to that. So I'm not sure if that it's okay or it's just like a side effect. But those were like the things I've been like exploring. And yeah, I'm happy like I hope people like play around with that, and then we can think about fun stuff. And actually, all of this started in Barcelona in the ICLC. Like my friend was like, "Oh wow, what if?"
Yes, we remember.
Yeah.
Cool stuff. So unless there's further question, we might have time for one more. I think we might be a bit tired at the end of the day for lots of questions, but thanks so much for your presentation, Sol.
Thank you.
Every
time I do like this, you don't see me, but I am like moving my leg.
Okay.
Yay.